get it right.
Offending you so
Fake
much.
news.
Okay.
Shut up.
Wow, y'all are ready to go on a Thursday.
I think so.
Do you want us to calm
I
down?
think that
I would love that. Just like a level of like, let's get through the lesson.
All right, everybody, let's get through the lesson. and
Yeah,
calm
let's
down
get through the
for a
lesson.
Hmm.
Take that word. Sorry, I don't have a brag for you today.
Fine.
have
Okay,
to,
so second part, we're doing the logarithmic equations. And then you'll be able to finish the second half of the homework. Remember, you'll submit all of that this evening. Guys, will y'all put your pens away, please? Thank you. All right, so we went through our product rules, the quotient rule, power rule, and all that. Hold on, this switched around on me here. That's what I needed. Here we go. So, from yesterday and from when we started this chapter, go ahead and set up this problem. This was one of those beginning problems that we had that at the time I told you to guess and check. Now you have all the information you need to not guess and check. Okay? You should hopefully start memorizing a lot of those formulas, but if you don't have it memorized, go ahead and set this problem up. Okay, so I would suggest just when we're setting this up, I would put A on the other side, because if you remember when we're doing around the world, the equal sign's on the right side. So if my original amount is 1,000, my rate is 5%, so 0.05. It says annually, so that's just a 1. And then we have our time, and we want to know how long it's going to take us to make $1,500. Okay. So before, I just told you to guess and check. So now we know we have to do what first? I'm sorry? Divide by 1,000. You have to get the exponent and its base by itself first before we can go around the world. I'm going to go ahead and change this to 1.05. And then now I can go around the world. So log base 1.05 of 1.5 is going to get me my time. If you haven't already figured that out, go ahead and type that in. And we should get that it takes us about 8.3 years. Okay, depending on if they ask you for whole numbers or if they want tenths place, if they want nearest half, any of those. You just adapt to what they're asking of you. Okay. So no longer do we have to guess and check and say, it's somewhere around 8 and 9. We can actually get an exact number. Okay. That's a little bit of a review from the beginning of the chapter and a little bit of a review from yesterday as well. All right. So let's look at solving logarithmic equations. So for my steps, people, here are your steps. You're going to get log by itself by either doing inverse operations and condensing. Okay. Then we're going to go around the world, which makes the logarithm disappear. Then we're going to solve for x. Again, you already have the extraneous solutions part written down from yesterday, but remember you can't take the log of a negative number or 0. We always need to check for those extraneous solutions. Okay? All right, let's look at some examples. So like I said, we already looked at these properties yesterday. We've done the around the world. But what is new are these down here. We did the bottom one yesterday, but the top one, okay? The top one, if you have log with the same base equal to log with the same base, you just take what the log is, let me see if I can say this the right way. What you're taking the log of, you just set those equal to each other, okay? So for example, I could give you log base 4 of x is equal to log base 4 of 5. And I would say, what does x equal? 5, okay? So we would just set those equal to each other and we would find our answer. This is not if anything's being added on or subtracted on or multiplied on or anything like that. This only includes everything that's inside here. Okay, now I can have stuff added on inside the parentheses. That's okay. But I can't have anything outside the parentheses or in front of the logarithm. And then the logs just magically disappear. Okay, it's not going to work that way. We already did the second one where if we had the same base for our exponents, we just set the exponents equal to each other. Okay? Here's our first example. This is home for us. This is easy. This is where we want to be. Okay? What is the base of a logarithm if nothing is there? 10. The logarithm, which means literally log, and what is in the parentheses is by itself. There's nothing in front of it. There's nothing after it. Since it is by itself, I can go ahead and do it around the world. And I have an algebra 1 problem. Go ahead and solve for x. You can leave it as a fraction. So x is just 103 over 4. And just like all these other problems, nothing is stopping you from plugging that back in to the original equation. And if you get 2, you got it right. So again, it's really nice to know when you got something right. Okay, so like I said, this is home for us. This is where we want all of our problems to end up. Okay, we want this to be where we can just simply go around the world and then call it a day. So of course, there's going to be other things that add on to them. And we'll have to deal with those as they come. But let's go ahead and knock out one more of these problems. Okay. Okay, then. My logarithm base, if nothing's there, is 10. I want y'all to get in the habit of doing a lot of these fractions without a calculator. My hope, things get back to normal a little bit next year when y'all have to take pre-cal, and then I can actually teach pre-cal the way it's supposed to without as many calculators involved. So we get 1 over 10. A lot of the trig stuff has y'all doing a lot of fractions, and that's why I say that. So if I subtract 3, I do some side work over here. So then if I multiply by 10, I get 1 minus 30 gets me negative 29 over 10. And if I'm taking negative 29 over 10 and I'm dividing it by negative 2, I'm technically doing negative 29 over 10 times negative 1/2. So then I just end up with a positive 29 over 20. Okay. So again, this is good. This is where we want to be. We don't have much we have to worry about, and so on. Any questions on those two? Okay. Now I have 2 logarithms, which is fine. We learned some properties yesterday that allows me to make that into 1 logarithm. So if I'm adding in between 2 logarithms with the same base, what do I do? What do I do? Multiply. Okay. Go ahead and solve for x. So since we're multiplying, we're running into a quadratic. And we should be doing these in our slate by now because I feel like we've been factoring like crazy. X squared minus 3x minus 10. What are factors of negative 10 that get me negative 3? Negative 5, positive 2. So then I get x equals 5 and x equals negative 2. Okay? So then looking back at my original question, do not fall victim to every single time you get a negative answer that it's going to be wrong. Okay? What you want to look for is if you do just see log of x in your original question, know that yes, if I do get a negative number and I plug that in, that's not going to work. Okay? But I just don't want you to think every single time that, oh, I got a negative answer, it's not going to work. Okay? So when in doubt, just plug them in and try them. Because if you got maybe log of x plus 3 or something, well, if I plug in negative 2, I can do that. Okay? So I don't want you to think every single time I get a negative number, it's going to be an extraneous solution. Okay? So I just want y'all to make sure you're plugging those in and actually trying them, because again, it's also testing to make sure you got the right answer. Okay. Let's try another one of those. Okay, since we are subtracting, we can condense by division. So log of 6 divided by 3x is equal to negative 2. And around the world, again, getting the habit with that negative exponent, I can go ahead and change that to 1 over 10 squared or 1 over 100. You need to see that in slow motion there. And then I changed it to 1 over 10 squared. And then I changed it to 1 over 100. Okay. So I'm going to go ahead and also change 6 over 3. You don't have to, but I'm going to go ahead and reduce that. Back to what, pre-algebra, was it, when you were introduced proportions? Was that what it was? Okay. Good old cross multiplying. We get x equals 200. Okay. Any questions so far? Am I going too fast? Okay. All right, so this is when we can condense. Now let's look at what if we have numbers in front of the logarithm, okay? So when I say numbers in front of a logarithm, what does that kind of set off a red flag in your head for? If numbers are in front of a logarithm, what does that mean? They're going to be an exponent, okay? So there's two ways I can show you how to do these next problems, and then you decide which one makes more sense to you, okay? So let's look at the first one. All right, so if I bring up my exponents, I'm going to treat this as a -1, too. I have log base 2 of x cubed is equal to log base 2 of 27 to the -1. Now, this is that new property. Since I have log, oh, yes, sorry.
So when you put the exponents there, do they go like inside of the parentheses or?
Inside.
Okay.
You're not squaring or cubing the logarithm. You're squaring or cubing or whatever. The x. Yeah. All right, so the new property says if we have logs with the same base equal to log of the same base, they disappear. We don't have to worry about them anymore. We're interested in solving for x using this, okay? So if I have 27 to the -1, that's the same thing as 1/27. And if I take the cubed root, it's what? 1/3. Okay, so that is if we want to pull those numbers up as exponents, okay? There's another way to approach this problem. I could add this log base 2 of 27 over. That's an option. It's a negative, so I can add that over. So I would have 3 log base 2 of x plus log base 2 of 27 equal to 0. Then I pull my 3 up. And since I'm adding, I'll multiply. So then I get 27x cubed on the inside. Okay, I just didn't write the 27 the opposite way. I can't stand it when it's behind it there. So if I go around the world, I get 2 to the 0 equals 27x cubed. Anything raised to 0 powers 1. And we're right at this step. Okay? So either way you want to approach the problem, go for it. It might surprise you which way you choose on the test. Okay? You might be like, oh, that first way makes so much more sense to me, and then the test comes and you create this. And that's totally fine too. Okay? Try this one that's down here. I know some of y'all are still writing that stuff down, so I won't scroll all the way. It's -2 log base 4 of x equals log base 4 of 9. Me personally, I'll move that -2 up. Okay, so x to the -2 gets me 1 over x squared. If that was really easy for you before, when it was a proportion like that, okay, then just make it happen again. So now I can cross multiply, and I get 9x squared is equal to 1. Divide by 9. Naturally, when we take the square root of both sides, we want to put a plus or minus, okay? But if we look back at our original equation, we have just an x inside of our logarithm. So if I plugged in a negative of my answer, it wouldn't work, okay? So in this particular one, we're just going to have x equals 1/3. Always check to make sure the negative, if the negative works, then great. If not, then only the positive. Yes?
So I assume so, but I just want to make sure it's set enough I'm not looking. So at the beginning of the problem, I multiplied like the exponents by -1 because I didn't want x to have a -2 as its exponent. I got 1/3. I just didn't know if it would only work in this scenario, like on here.
Like on this step right here?
No, I multiplied -1 by like the first part, but just the exponents.
I mean, usually the rule says if you do one thing to one side and you do it to the other, then you should be fine. So
I got 1/3, so
oh.
I just didn't know.
So that became 1/9, and that was x squared?
Yeah,
Okay.
x squared equals 1/9.
Yeah, usually if you do one thing to one side and you do it to the other, then it should be equivalent. You know what I mean?
I just didn't know if it was like some weird coincidence.
Yeah. Sometimes they are. Sometimes they work out. Now, if you were like, I don't like a negative, so I'm going to multiply that by a -1 and then did nothing to the other side, then that'd be different. It's almost like what you really did is that you flip-flopped. Like you added this to that side and you added or subtracted that to the other side in more ways than one. Yeah, good question. Any other questions? Okay. Well, these are great when we have log and what we're taking the log of, but we can't have anything extra. So in this next example, I can't just say, oh, there's a log and a log, one on each side. I'll just make them disappear. Okay, that's not how that works. They can only disappear if that one wasn't there or if this one wasn't there. Okay, so what we're going to have to do is we're going to have to make this into one single logarithm. Well, if one's over here, I'm going to subtract it over. And since we're subtracting between two logarithms, to condense them, we're going to do what? Divide. So go ahead and finish that one out and then try the one below it as well. Make sure you try both of them. Okay, so if I am dividing, and I go around the world, I have 10 to the first power. If you want to put it over 1, you can cross multiply. If you want to just look at it and say, oh, I can just multiply by x minus 2, you're going to get the same answer. So 10 times x minus 2 is equal to 7x plus 1. So 10x minus 20 equals 7x plus 1. I'm going to subtract my 7x and add my 20. So I get 3x equals 21. So x equals 7. Okay. Like I said, you can always check your work by plugging 7 back into the original and seeing if you get the same answer. What I would do is I would go ahead and plug this in with 7 first, and then plug this in with 7, and then see if you get the same answer. That's how you see it there, of course, equivalent. Okay, down here, again, I'm subtracting. So I'm going to write log base 9 of 2x minus 10 over 2, which is nice because that cancels out a lot of things for me and simplifies. 9 to the first power is going to get me 9, and I'm left with x minus 5. And if I add 5, I get 14. Okay. And again, I could plug that back in for x and check and make sure that I got it right. Okay. Any questions on those? So hopefully now you see what I was talking about when I said, when we learn around the world, when we learn expanding and condensing, it sets us up for solving. Okay. So everything we've learned so far, we're using on these problems. Okay. Let's see. Let's try both of these. too. All right, so if I am going to condense this and then go around the world, I have 2 cubed is equal to x squared minus 7x. 2 cubed gets me 8, so I'm going to move that over. And my factors of -8, they get me -7 or -8 and 1. Which makes my solutions 8 and -1. I'm just going to kind of look up here. There it is. Where just x is by itself. If I plug in a negative number, I know that's not going to work. So 8 should be my only solution. Okay. Over on this one, same idea. I'm condensing. I'm going to multiply these two together. Did we already do this one?
Yeah.
No, we're just going to let me redo this over again.
Yeah.
Copy paste from the other one. Sorry. That's my fault. I thought it would be different. And then I was like, wait a second. That's going to get me 10 and -3x. Same answers as before. We did one of those. Did one of those. We did one of those, so we should be good. Okay, take a quick break.